I'm going to talk about how to make an electric motorboat. First, design, build, and test a fan boat. Where a fan boats are used, a fan boat doesn't have a propeller in the water. It is propelled by a giant fan. This means it can be used in shallow water and swamps. It can also be used for float and ice rescue operations as we saw in the images. Learning objectives. Learning objectives. First, predict which materials will float. Understand the forces acting on a fan boat. Make and use simple series circuits. Get to know the general design process. Step 1 is introduction. Step 2, design criteria. Step 3, prototype. Step 4, manufacture. Step 5, test and probe. Step 6, discussion. Working safely. Look at the tools and equipment at the sample boat. Can you spot any position hazards? Can you think of ways to reduce the risk? Do not put the spinning propeller near your eyes. Do not put your fingers in the way of the propeller. 2. Why things sink or float. Archimedes was an ancient Greek mathematician, physics, and engineer. He discovered how buoyancy works. If an object is heavier than the same amount, it means volume of water, then it will sink. If an object is lighter than the same amount of water, then it will float. Floating exercise. Identify which items are made of metal, wood, glass, rock, or plastic. Which of the materials do you think will float? If solid polystyrene sinks in water, why does foamed polystyrene float? Which material could you use to make your boat and why? Where to put electrical parts. 6. Think about where are you going to put your electrical parts on your boat base. What will happen if the center of gravity is too near? The front? The back? We have to measure this and the electrical parts to understand if the boat will float or sink. What if it's over to one side? Designing your boat. Sketch a design in your workbook to fit your design criteria. Think about what materials you have available, like foam, like polystyrene, or metal. Why? Sorry. Imagine the resistance of the water. What shape will cut through the water easily? Don't make the base too small or too narrow. Make a prototype from card. Electrical parts. Name these electrical components, like a motor, a switch, and a battery. Well, wires too. This shows the electrical circuit you will make. It's simple. Using circuit symbols instead of actual components make easier to draw. You have to put the motor and the battery, one line, the positive to one pole of the motor. The other pole of the motor is going to attach to the switch, one pole, and the remaining pole to the battery, negative. Avoiding short circuits. If batteries are short circuited, they can get very hot. Do not connect the metal ends of the wire from the battery directly together. They must be connected across the motor. Also, tie the black wire and the red wire from the battery clip in the ref node to stop bare ends touching. Make sure the plastic sleeves covered with the crocodile clips as shown here to help prevent short circuits if the clips touch. Making your circuit. Collect your electrical components. Tie the black and red wire from the snap battery connector if you rig knot. Then push the connector firmly onto the battery holder. Lay out your components in a triangle and connect up the circuit. Clip cocoa railets onto the bare metal, not onto the plastic insulation. Fit the cells into the battery holder the right way around. Switch on and check the motor shaft rotates, then switch off. Making your boat base. This is the final step. Making your boat base. Draw round your prototype one of your pieces of polystyrene foam with a felt tip pen. Check your design with an adult, then cut it out using large scissors. Place this on a second piece of polystyrene foam, wrap around it, and then cut it off. Glue the two pieces together, making your boat. Clip the motor into the motor mount. Lie on your electrical parts on your base. Make sure the center of gravity is near the middle. Mark the positions with felt tip pen. Seal your battery inside the plastic bag with the wire sticking out. This is to help prevent it getting wet. Keeping your electrical pot dry. Make a double thickness raised platform of polyester foam output to stick the battery on. This is to help stop it getting wet. Make a raised platform the switch as well. Glue this onto the boat base, then glue the battery and switch on them. Assemble your fan. Stick your cotton reels onto your boat base, one on the top of the other. Remove the plastic film from the motor mount sticky pad and stick into the top of the cotton reel stack. Hold the motor and press the propeller onto the motor shaft. Turn the propeller all the way around with your finger to check it doesn't touch the cotton rails. Completing your boat. Fold the cocoa railets neatly and tape them together. Make a pilot for your boat using a pine cone or wheelie eyes. Add any other features you have planned such as size, a motor, house, fans, etc. But make sure you don't block the airflow to the fan. Decor your boat. Testing your boat. This is the final. Well, switch on. If the propeller isn't spinning, can you work out? Why not? It is catching on the cotton reels. Has a connection come loose? Try it off your boat in the water. Try. If the boat goes going forwards or backwards. If it is going the wrong way, you could swap over the cockle clips attached to the motor contacts. The propeller will fit either way round on your motor. It works much better on one way than the other. Can you work out which way is the best? Well, the third tip, it is important because if you attach the connections from the battery to your motor in the positive polo to the negative polo side by side, that's all. Thank you so much for watching.